the food dye number 75, right here. So this one right here, they say that we saw this in the previous lesson, but this is the food coloring right here that Good Food Production uses in many of its products. So let's listen.
This is the food dye that might be harmful. Red dye number 75. This is the food coloring that Good Food Production Incorporated uses in many of its products. We will test to find out if it's a mixture that could contain red dye number 75.
Okay, so then the question is, that Good Food Production wants to know whether the food coloring is a mixture or a pure substance. We already have determined that pure is natural, that nothing has been added, and we have already determined that a mixture is something that has been added. Okay? So we're going to use this technique, and it's going to come up. It's called chromatographic. It's a technique that scientists use to separate mixtures into their parts. And we're going to see that set up in a few minutes. We would know if food coloring is a mixture after the test, and we will see the dye separate from the food coloring. So what is food coloring? Everybody knows what food coloring is. We've seen it, right? Food coloring is what? Okay, food coloring is something that changes colors. That's what he said. It's a dye that what, baby?
It's edible.
It's a dye that's edible. Good job. We will test to find out if this is a mixture that contains dye number 75. And when we test something, we know that we do what? We observe it, or what is it? When we test something, we do what? We make notes about it and things like that. Yes, wake up, baby.
Remember, we observed this food coloring when we did our food mixture investigations. The president of Good Food Production Incorporated wants to know whether this food coloring is a mixture or a pure substance. This concludes activity 1. Let's continue with activity 2, separating the food coloring. Let's take a look at something that is part of the chromatography test, which we'll use to investigate the food coloring. We are going to watch this video to
We're
help
going to
us
watch
get a
this
better
short video to help us understand it. So I'm going to explain to you what they're doing on this video. So what they're doing on this video here is called separating the food coloring. You're going to observe how water climbs up, and then how they're going to use the test to test the chromatography to test the food coloring. So here, they took a piece of paper towel right here, and they dipped the end of the strips in the paper towel into the water. Okay? Now, if you notice that you're trying to see if the water is going to climb up the paper towel, because remember, molecules are attracted to what? Other what? Molecules are attracted to what? Other what? Molecules are attracted to other. I told you in the beginning that they are highly attracted to what? Other what? Other molecules. So molecules are attracted to other molecules. So what do you observe? What do you think is going to happen? Let's go ahead and predict. Do you think the water is going to climb up kind of up the paper towel? What about you? Kimonte? Oh, yes. Markel? Yes. Jakarn? You gonna do what?
I think the food color is going to climb up the paper towel.
But we don't have food color right now. But you're saying when we add the food color, you think it's gonna climb it up too? Climb up? Okay. Thank you for thinking in advance. What do you think right now that the water is gonna do what? You agree with him? Janaya? Janaya? Janaya, wake up, baby. So right now, they put a paper towel into this water. Do you think the water is gonna climb up the paper towel, or is it gonna stay where it's at? You You think it's gonna climb up the paper towel? Okay, good job. Let's see. And the reason why we say that, because remember, the attractions of molecules. So if you notice then the water is climbing up the paper towel. And the reason why it's doing that is remembering because water molecules are highly attracted to other molecules. The water molecules are attracted to the molecules in the paper towel. So what they're saying here, and Ms. Williams is going to kind of try to show you guys here with a little drawing. So we're going to use blue, and we're going to say that this is the water. And we're going to say that this part right here is the paper towel. This was the paper towels, right? But look how far the paper towels was. All this was the paper towel that they dipped down into the water. But if you notice, because they are highly attractive, you'll see that the water ends up climbing all the way up to here. And why is that? Because what?
Molecules are attracted to other molecules.
So the molecules in here, in the paper towels, are attracted to the molecules
that are in the water.
that are in the water. Good job. Okay? So everybody understand that part? Thumbs up if we understood that so far. Good job. So the test technique that we're about to see is that how involving the strip of water, just like we observed, we're going to, in the test, the water climb up through the test mixture. In this case, we're going to test food coloring. So we're going to use, so we will put a line of food coloring on the paper. You will position the paper to soak up the water, and then we will observe what happens to the line of the food coloring as it climbs through. So let's see if these two guys right here, prediction is correct.
In chromatography, a paper strip is dipped into water just as we saw. In a chromatography test, however, the paper also has a test mixture on it. You can see by the diagram on the left.
Alright, so this is what we're about to do. So let's go ahead and clear this out so I can show you guys how the mixture is going, and we're going to see whether or not it's going to do it or not. So, on this one, this right here is the water. Alright, we're going to use the red for the food coloring. And then we're just going to use a little black line. We're going to make it a little thick so you can see. So we're not going to actually do this observation, but you'll see. And so this is the paper strip right here, and it's hooked up to the pencil. So we're trying to see whether or not it stays separated or if the red dye is going to go up the paper, okay? So pay attention.
You will hang the paper strip so the bottom touches the water. What do you predict will happen?
Okay, so we know that Taylor said that the red food color will go up the paper strip. Mr. Hiram said that. What you say, Connie? Will it stay separated or will it go all together and go up the paper? So staying separated means that when we take that piece of the paper out, the water is gonna be clear at the bottom, it's gonna be red right here, and it's gonna be clear right there. What you thinking? It's gonna go up, so it's not gonna separate? What you think, Martell?
I think if it's 70% red, it's gonna stay separate.
Oh, I love how you included so you saying, you thinking, okay, so you're saying that because it's the number of the dye is dye number 75, because the number is so high, you think it's gonna stay separated? I like the thought process.
Pause the video and answer this now. Your job is going to be to carefully observe what happens to the food coloring as the water climbs up through it. If it is a mixture, it will separate into separate dyes, and you will be able to see if it includes red dye. Turn to page 9 in your
So this is the
workbooks
one
or a
we're
blank
doing
piece of
the
paper in
project.
your notebooks, and let's review the directions. Using chromatography to separate a mixture. 1. Draw a pencil line on the paper strip. Draw a pencil line along the top edge of the food coloring. 2.
And you can also
Attach
do
the
this
paper
at home
strip
if you
so it
want to
hangs
do
in
that.
the water, but the food coloring is still above the water. Tape the top of the paper strip to a pencil. The bottom of the paper strip should just touch the water in the cup, and the food coloring should remain above the water. In step 3, start the chromatography test by hanging the paper strip in the water. Place the pencil across the top of the cup. Chromatography
It shows
test.
you how you
Again,
do it.
here are the directions. Step 1, draw a pencil line. Step 2, tape the top of the paper strip to a pencil so that the paper strip will hang in the water with the food coloring still above the water. And step 3, place the pencil across the top of the cup to begin the test. If you are unable to perform this test yourself, watch the next video and it will be done for you.
Okay, so let's watch this video and see exactly what happened.
Hey scientists, my name is Mr. Hope, and I'm going to be doing a couple of videos with you guys
Notice she
during this
calls
season.
us scientists.
So we're going to do our first hands-on activity. So scientists, let's take a look at something that is a part of the chromatography test, which we'll use to investigate the food coloring. I want you to notice what's happening with the paper towel and what's happening with the water.
So once again, what's happening with the water?
It's the water line or running to the bottom.
Why is it going up?
Because the water
Good job.
Did you notice what it did?
Did we notice what it did? It's doing what? Climbing up the paper towel.
Let's watch it again. I want you to pay close attention to what happens to the water once the paper towel is put into the cup.
Oh, let's watch. So look how much water is in there now.
So pay close attention and saw what happened to the water when the paper towel was put in. So scientists, in chromatography, a paper strip is dipped into water, just as we saw. In a chromatography test, however, the paper is also has a test mixture on it. And so in our little picture or diagram, you can see that we're going to put some food coloring on our paper strip. Okay? We're going to see what happens. So, what do you predict will happen when we put our paper strip that has the dye on it into our glass of water? Can you make a prediction? What's going to happen? This is what we're going to do, scientists. First, we're going to draw a pencil line on our piece of paper. And the dye is already in the other paper.
So we're gonna already take our paper, our piece of paper, and put the dye on there. So we put the pencil line, this is the red dye, and we're gonna do that part in water. We're trying to see if it's going to separate or if it's gonna all come together.
We're going to tape the top of the paper to a pencil so that it can hang in the water with the food coloring still above the water.
Stays above the
Now we're
water.
going to place the cup across the top and begin the test. Alright, so let's go ahead and get started. Alrighty, scientists, let's go ahead and see what happens.
So pay attention.
You can see we already have our paper strip with the dye on it.
There's dye not red.
Now
but it's okay.
I'm drawing that pencil line.
She's taping it on there.
happens once it's put into the cup.
So now she's putting it in there, but keeping the dye above the water line. Now we're gonna see if our prediction is right, what's gonna happen with the dye.
Close attention to the paper strip.
Uh-oh, what is the dye doing?
They don't even know. Oh, great.
Let's see if it's gonna continue to move. Alright, so what we noticed so far that the dye is doing what? Climbing what? Climbing up the what? Climbing up, what? No, it's climbing up the what? The paper towel. Why is that? Molecules are attracted to what? Other molecules. Let's continue to watch.
So we put it in the water and some things happened. I'm going to show you a picture after I took it out and let it dry for a little bit. So scientists, here is our paper strip after I took it out of the water and I let it dry for a little bit. So you can see the pencil mark is right there. What are some observations you're making about what happened?
Okay, so what is, let's go over there and look at our observations. I'm sorry.
Alright. So we put it in the water and some things happened. I'm going to show you a picture after I took it out and let it dry for a little bit. So scientists,
Okay, so we're scientists. What do you guys notice? What do you notice? It changed colors. What do you notice? It changed it because what color was her dye originally? Green. What do you notice, Taylon? It was green. What else you observed about it?
I observed that the top is blue, and like the lips are a bit yellow.
Yellow. So you notice different colors. Okay.
I noticed they have blue at the top, green, in bottom of the blue, and then they have light blue, and then,
Like with
pink, and then green all the time.
Okay. Markel, what do you notice?
It changed colors.
It changed colors.
I noticed that it turns color bright when it touched the pencil. Started changing color bright when it touched the pencil.
When it touched the
The
pencil.
pencil line.
Oh, so you're saying you noticed that it started changing colors as soon as it started touching the pencil line. So do you think us putting that pencil line had something to do with the fact that it changed colors? Because it was what? Black, so you think it's because it has something to do with the color? Alright. What I noticed is that yes, the molecules are attracted to other molecules, but I also noticed how it spread it out and also how it changed colors as well. I noticed how it went past the pencil line also.
I noticed something.
Okay.
I noticed how the water separated from the color. It got water.
How the water did what?
separated from the color.
How the water separated from the colors, because that's what we wanted to figure out, whether or not the water would not do what? Separate from the dye on the paper. Good job, Markel.
Here is our paper strip after I took it out of the water and I let it dry for a little bit. So you can see the pencil mark is right there. What are some observations you're making about what happened? To yourself.
Alright, so let's just go ahead. So after we did all of that, we observed to the food, okay, started doing it. Long enough, you can see that the food color began to spread. We observed more in a few minutes, and that the chromatome test it began to interfere with their results. So the test, when we did this test, it began to interfere with the results of what we wanted to get information about. Okay? Let's see. So just some background information. Water molecules are attracted to one another. This explains why water has so much surface tension and thus forms water drops. Water molecules are highly attracted to molecules of many other substances. Water climbs up the paper towel because water molecules are highly attracted to the porous paper towels. The water molecules moving up the paper towels bring even more molecules because of this highly attraction between the water molecules. Why do you think we did the testing? Why use the test? The prime reason for engaging students in using the test is to provide a context in which the students can understand the matter of the nature of matter. Alright, so we have learned that separating food color with what they have learned about molecules, that they construct and refine ideas about substance, mixtures, molecules, and properties of molecules. Let's see. Should be almost finished.
Let's continue with activity 3.
Alright, so we're gonna stop right there for today, you guys. So today we learned about what? Molecules. Molecules are what? Okay. Have we figured out whether or not the dye is harmful yet?
No.
We're still figuring it out. We learned about pure. Pure is something that has what? That is
That
what?
is naturally known.
That's natural. We learned about mixtures. Mixture means they have a combination of something. And we learned that molecules are highly attracted to what? Other molecules. Alright? So that's today's lesson for separating food color. Thumbs up if we understood today's lesson. Caleb, I know you just came in, but you'll catch up on tomorrow, okay? Alright. Good job. Good job.